We know Darwinian evolution as the process that has created complex organisms from simple cells. If we basically argue that the same Darwinian principles have worked on some kind of molecule in order to create a first cell, then RNA is perfectly suited for this, because RNA can self-replicate, RNA can mutate, and RNA has catalytic functions that can be optimized by the process of selection. The problem is that RNA is already a relatively complex molecule, and the question is really, how do you come from the simple starting materials, for example, CO, carbon monoxide, water, ammonia, hydrogen cyanide, and so forth, to such a complex molecule? Here, our work is, I believe, a strong contribution, because we show that small molecules can assemble not to the RNA molecule, but to the nucleosides that later form the RNA molecule.
Nucleosides are the smallest segment of RNA that you can have, and lots of them can come together to form a longer molecule of RNA. There are 4 nucleosides that make up RNA, and these can either be called purines or pyrimidines, depending on what their chemical structure is. One of the big problems with the RNA world theory is that nobody has been able to show exactly how to get from those simple chemicals on early Earth to the purine nucleosides, which are chemically pretty complicated.
That's always a question. What is hard to make? I think the purines are really cumbersome to make. And what we show is that these purine nucleosides, they can form using this pathway that we call chemical FAPU pathway, so we call it the FAPU route. Using this route, these compounds form much easier, much cleaner, in much higher yields.
This chemical FAPI pathway relies on using the chemical building blocks on early Earth to make formamidopyrimidines. Try saying that 3 times fast. This is where the name FAPI comes from. And these FAPIs can then be combined with simple sugars to form the purine nucleosides which are needed to make RNA. But aside from working out how life started on Earth, I wondered whether this route they've discovered had any other applications.
Well, the route in principle allows to synthesize a diverse set of purine and maybe in the future also pyrimidine nucleosides. And since nucleosides are pharmaceutically active compounds that are ingredients of antiviral therapeutics, they are part of cocktails given during an anti-cancer therapy, I think our chemistry may have the chance to provide new nucleosides with interesting pharmacological properties.
So there are potentials for life on Earth now, as well as for discovering how it all started. But why does Thomas think our origins are such an important puzzle?
I believe that it is extremely important to understand the forces that allow molecules to assemble into something that we call a living organism. We send space missions out in order to look for life outside the Earth. Are we alone in this universe? How is life created? Is this really a single accident that happened on Earth, or that general phenomena that allow dead matter, basically organic molecules, to assemble into something that is an organism at the end? I think this is a very fundamental question.